Researchers discover dozens of new exoplanets each year, and it's quite possible that we'll soon find a world similar to Earth that we can inhabit. But how would humanity travel to these alien exoplanets trillions of miles away? And what kind of technology would we need? And it seems nearly impossible to travel so far across the universe. But scientists recently discovered something in our own solar system that might allow us to travel faster than was previously thought. And we've just picked up. Now, before we get into that, let's traverse just how far away are some of these exoplanets, how fast we'd need to travel to get there, and what kind of technology we'd need. The closest system to Earth is Alpha Centauri's triple star system. The third and faintest star is Proxima Centauri. Two exoplanets orbit this red dwarf star, and one of them, Proxima b, lies in the habitable zone, or what some scientists call the Goldilocks zone. Now, the Breakthrough Listen project detected a strange radio signal. The narrow band of the signal makes us speculate that it is from an advanced extraterrestrial intelligence that can only be technological. The challenge to space travel is the distance that we need to travel. Proxima Centauri lies 4.2 light years from Earth. A light year is the distance that you can travel in 1 year, which is 6 trillion miles if you could travel at the speed of light, which is 186,000 miles per second. So actually it would take you 4.2 years to reach Proxima Centauri if you were moving at the speed of light. The fastest spacecraft is the Parker Solar Probe, which is currently on its way to the Sun. On October 29, 2018, the probe reached the speed of 154,000 miles per hour. By the time the probe makes its closest approach, it will be traveling at 430,000 miles per hour as it's pulled by the gravity of the Sun. Even at that speed, it will take the probe 6,600 years to reach Proxima Centauri. Just how fast can humans travel safely in space? The current speed record is held by 3 astronauts who flew the Apollo 10 mission. On their way back from a slingshot wrap around the moon, the Apollo space capsule hit a peak speed of 24,719 miles per hour. At that speed, it will take 113,000 years to reach the Alpha Centauri system. Chemical-powered rockets have taken humans to the moon, have made countless missions into Earth's orbit, and have powered long-range missions in and outside of our solar system, like the Martian rovers and the Voyager probe, which was launched in 1977 and is now in interstellar space. The problem with current space travel is rockets need to be refueled, and there are no refueling stations in space. We'd need something else to power our spacecrafts. Speeds of 24,000 miles per hour may seem fast, but it's not fast enough to travel to the distant exoplanets or the countless star systems that surround our own solar system. Now, the direct fusion drive is a futuristic conceptual low radioactive nuclear fusion rocket engine that will be able to produce thrust and electric power for interplanetary spacecraft travel. The drive is now in development at the Princeton Plasma Physics Laboratory, and the researchers working on the engine hope to launch it and test it in space, hopefully use it as a primary drive for spacecraft use in our solar system.